Do, 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 do.
How's your day going? Good.
How do I make this move?
I don't know what to do. I don't even know how to start. I don't even want to do what I'm doing now.
I don't want to start
It
moving.
must be 16 pages. You're just 16 pages?
That's 16 pages?
The global concentration?
The paper for your concentration?
It's a capstone.
No, this is something you write for senior project.
Wait, what is that for?
What's what for? This?
I don't know, I just want me to do that, so I can't do it anymore. What?
So like, the concentration program where you can
What's it?
focus your classes that you take and you can get like kudos for graduation. The main thing is it's a capstone project that elevates senior project to a more academic, rigorous kind of thing.
Did you?
Well, it's time. What time is it?
No, but you have one for that.
1:13.
Yeah, let's do that.
It's 1:13. Oh my gosh, we're late.
1:14 actually, and 5 seconds.
Oh my gosh, Eliza.
She's talking to somebody.
Eliza, can you please close it?
Who's checking? Who's checking? Lu's on has a phone call. She's
Someone
on the
needs to.
No, Lou's talking
You're
to Tom. Yeah.
What are you doing? Alright, hey, so let's chat. We got a lot to cover today. We got a big project that's coalescing. We have a big pond report. Hey, hey. Yeah. We're about to literally more time. We'll go about later. But we have this campus pond report that we have to write, and we have to do some math. We have to turn some observations into a number that tells us a story. And so today and tomorrow we're looking at methodologies that turn our observations into quantitative data with a formula that we've been using over the past couple of years. Okay? And part of it is we have to be able to, in order to do this, we have to have our data set up well. So what we're going to do today is we're going to make sure the biotics part of our study is square and ready to roll for your reports. Okay? A couple reminders about the report are up here on the board. So it says one of the things you got to remember with the report is that you have to make a map of the campus pond watershed. I will show you an image of what that can look like in a second. And then we're going to focus on updating our data chart so we can do this biotic stuff, this math, and then we'll compare it to the past. Okay? So, step one, let's talk about the map and let's talk about past data. You can get a 2-for-1 deal by simply going to a past blog. And the one I recommend for last year is Sarah Ferdinand's. This is hers right here. You can easily find this in our blog website. It has all the classes over several years. Let me just show you what she did for a map. Very easy. Look at her materials list, by the way.
So this is not like much, I guess,
Just now beginning to scroll, my friend.
right?
But here's the map. Here's the map. This is really cool what she did with the map. Did you see that okay?
Yeah.
No? Should I turn off the light?
No.
So this, all this is what, actually Anna did this. She credited Anna for doing the work. And you can do this. You can take any of their stuff from their websites as long as you credit them.
So I can
And
take
so
that map if I want. Just take.
If you want to take that one, yeah. You can just screenshot it.
Can I
Right?
screenshot the whole blog?
Yeah, just
like,
kind of-
Oh, you know, come on, we're not writing, right? It's not what you discover. That's a big fat zero. Look at the map, look at the map, hello, the map. She got this map from aerial photo from Google Maps or Google Earth, and they're totally legit to do that. And then she put it in Notability, and she wrote on it, and created these, indicators of the flow chart where it's flowing. And so it's pretty important that you talk about the map, because one of the things that's important is that we're studying, this site. Where does this water eventually go, though?
Out. To the
Out.
water.
To the water. I like how Alex did this slow motion. I was just copying her. She's really amazing. But what's the watershed include? What does that include? Where is it going exactly? The Blackwater River. So it goes underneath this path. It goes underneath past Slocum, in between Wise Center, past maintenance buildings. It dumps out on the other side near Drew's house, and then goes underneath the road and into the Blackwater River. So, but we don't care about the water once it leaves, because that's already affected our pond, right? And the animals in it that we've been studying, the community we're studying, correct? So, one of the things that's asked in the report is for you to know where the water comes from. And it is the watershed. It's the watershed. Are you ready for my Halloween
Is
rules?
this due Wednesday?
Yes. Yeah, panic.
Thursday.
The first, yes, please. I mean, it's Thursday. Thursday. The first of November. Look what she did here. Check it out. Check it out. Look at this path. You see this? Can you see it?
Yeah.
If not, we can turn the lights off.
Oh, I see it.
All right, so here's the pond over here. Here's site 1. Here's site 2. There is a underground tunnel that flows. The water flows through from this river way over here on the other side of the hockey rink. Goes underneath of the culvert. Goes underneath and comes out there. All the drainage sites in the turf drain come out there. Okay. And then this same deal. What's interesting about this, and I think it'd be good, I just turn off the side. Sorry I'm making you be the AV person today. Oh, he's injured. Lucy will be next. Just this one. Yeah, good. That's good. But look, if you look, no, don't turn off the light. No. Don't listen out. Notice the little black dots. Where do you think those little black dots are where the arrows are pointing to? Black dot, black dot, black dot.
Train.
Trains. Ding, ding, ding. Good, you read the law. You read it. Those are drains. So what does that mean for the pond? If water's draining through those grates, and there's another one here, there's another one here. It what? What is going into the pond?
Rainwater.
The rainwater. What else is in there? I heard it. Some sort of contamination. What would specifically be some contamination that's going in? Who would do what? Turf pellets? That's from the turf side. Yes, turf pellets. Oils from all the cars parked there. What else?
Trash sometimes they make.
Trash, yeah. What's been happening here? You kind of see it in the front.
Dirt.
Construction. What do you see right there in that construction zone?
Dirt.
That's before the dining hall's finished, right? Now we have this we're working on, just a little of the dirt. So the dirt, the sediment can run away when it rains. Have you noticed the path to the dining hall? How it's gone from grass to just a mud road. So that water, that sediment's now loose, and it's going to drain into a drain and then into the pond and bring some nutrients to the pond, for good or bad. Something to think about. Okay? So we know this. So we know that diversity's had, that this construction and stuff has had an effect on diversity. Here's the diversity index. This is what Sarah's class created. They have their chart here. Diversity index of Hive 20 right there. They calculated. Notice in 2007 it was 19.3. This diversity index, and it goes.
Did you not do it in 2009 and 2011?
That's right. In 2009, we had a problem, which I'm going to go over in a few minutes. And in 2011, I was like, you know what the heck with this pond? I'm worried about skiing and all the detergents we use to make a snowflake and how that enters the aquatic system. We got to test that because that skiing stuff's evil. No, I didn't say that. I was worried. But I found that that site was really hard to test, hard to get good results. We had a lot more variables and said, bleh. So we just skipped that year and just tried something new. So we have this trend, 19, 15, 11, 7, 12, 7, 6, 6, 7. What is it this year? We're going to find out. Okay? So last night you did some math, right? You tried some math around this Simpson's diversity index, right?
Yeah.
So now we're going to shift to talking about this set of data. We're going to first talk about the process, then we're going to talk about the actual data. Okay? So process first. Let me go to my next thing. Process first. So, the Simpsons diversity index. A couple things about it. The Simpsons diversity index, and this is an important thing to take notes on. If you didn't take notes on the video last night to understand it, this is your moment to clarify. There are several different mathematical or statistical models used to calculate diversity. The AP curriculum tends to like the Simpsons diversity index over the Shannon-Weber or Werner diversity index. I like this one too because it's easy to explain and the math doesn't break my head open as much as other stuff. Being a person who suffers from math anxiety and a slight form of anxiety-induced dyslexia, I like this one. And we need to understand though, what is so great about it. What is diversity actually measuring? What is this index measuring? Remember the video. Prove to me that you got the video a little bit. What is it measuring? There's two things.
The diversity in samples.
The diversity in what?
In samples. Like he
The
did
diversity
samples
in samples.
and
Okay.
the species within the samples.
That's right. And he was specifically, we have these figures in here of n and little n. Right, two different qualifications that we're measuring.
The total number of organisms in the community.
Right, that is correct. So they're measuring two aspects of diversity. And this diversity model we can use for any population. We can use it on Proctor standards, for example. In this room, we wouldn't get very much diversity, would we? Ethnically speaking. Gender, we would probably get some. But there's an important measurement that's done when we look at diversity. There's two things. There's richness and evenness is measured. And our guest speaker in that video from that other school talks about it a little bit. Do you know the difference between richness and evenness when we're looking at biodiversity or diversity measurements? Richness and evenness. And notice I put them next to those number values because they relate. What would richness be measuring? The total number, right? So right now, if we did total number in this room, we've got a total number of different genders in here of 2, right? There's 2 genders that are easily identified, anyway, we could say, right? If we did evenness, what are we measuring?
Number of individuals.
The number of individuals, so the actual diversity. And so, if we looked at the evenness of it, would you say we're diverse in this room based on the amount of males versus females?
No.
Is it even?
No.
No. It's 4 to 10, something like that. Right? And so the same with our insect population that we looked at, our macroinvertebrates. We're doing that. And why is there a -1 in our calculations? Well, how is that explained?
The declining of the,
And why do we have that?
because of the data, each column had different numbers based on the individuals within that.
Okay. Well, and so why do we use a -1? What's the point of a -1? Because we do -1 in each of the calculations. I have a calculation here. Why are we doing -1?
Oh, does it have to do with the ratio?
Well, it's set up as a ratio, but we do -1 because of a statistical issue.
I don't know.
All right, let's do this. What if we had the ratio of gender, we only had 1 male in here, and then we had everybody else is female? We could say that there's 2 different types in here, but does one really represent diversity?
No.
No, it doesn't. In its statistics, it can be considered an outlier. It could be an anomaly. Just one doesn't make a population, right? You need 2 to tango to make a population, right? So we have -1 to round out any outliers, so we don't get a false number for diversity. Because one species being present and one individual of that doesn't make the sample diverse. It's kind of like tokenism. If we have one black teacher in the science department, that doesn't make us racially diverse as a science faculty, does it? Having one doesn't do it, because it's an outlier, it's not enough. It's not enough, okay? And I know I'm mixing human constructs with biological, but it sometimes can help. Let's just do the numbers then. I gave you a data set to try to calculate the numbers. We're going to go over your answers in a minute, make sure we got it. But I'm just going to come by and take a look at what you tried. Because making mistakes is fine. Efforts matter, so I know where to start with this class activity, okay? So get that out. I want to see it. I'm going to come around, each one of you, and we're going to see what happens. And then we're going to do some real data, okay? Here we go. Who shall I start with? Sam. Sam is like this. Okay,
This one is.
here we go. Yeah, you know, we were supposed to go across. Yeah, you can do that. It looks like you're drawing, it looks like you're getting there, you're doing this number here. We're gonna try some more, no, it's good effort. I just wanna see how they try. We're gonna do some real stuff. It's good, good, I'm gonna help you out. You did a lot more complicated than you did. So that's what's good, it's gonna get simpler. Let's see how you do.
No, I got them wrong. You two got.
So your answer is that at the end? No, that was good. You almost had it. We're gonna go over and make sure you have it. That's all right. I'm not carrying it for wrongness. You gave a good effort. Is this, you did it by sight. Did you do it by sight? You did it by total. Yeah, you did it by total. The process is right, but we're gonna do it by totals. I'll show you. Don't worry. You got it going on. It's good. It's good. You see what you have. You did it by sight as well. The math is right. Good. We're gonna do it a different way. We're not gonna do it by sight. We're gonna do it by total. That's okay. That's okay. The math activity part is the same, and that's what matters, because we're gonna make our real data set together. Okay? Where were you able to get to? Let me see, Charlotte. Yeah. That looks great. Looks like you get an idea of the math. And then we're going to apply it to our data. Okay? Give me the sheet. Same. Good. Excellent. No, it's not by sight. That's okay. The math is what I care about. That you're doing the process right. That looks good. Here we go. That's the correct answer. Did the total. Good work. Good work. Good work. You did it by sight. You did the right math.
Right now.
Goody. Thank you. Well, you did it by organism. Okay. You just have one more step to go. You'd have it there. You can do it in class. I want you to try it. Feels like the data set was attached.
Wait, what?
To the assignment.
Your dog is like Banner.
Oh, thanks.
Oh, it's oh my gosh, I think Kingsley. It's like a little like
It's so
there. Like I didn't think it was nice.
Yeah, I know.
We can go up right now. Just hang with us. All right, so look. All of you got the basic math mechanics down. But what we want to do with this is, it looks like a lot of you got it cut off. You didn't go to the whole thing, the totals. So you start with the totals here by species, right? So the way this was done, this is the data from 2017. And so I just took a quick screenshot of part of their data. And so the way they were reporting out the data, and you should listen to this because we're going to do it in a second, is that for their class, they wrote down the maximum for each site, and then they added it up. So the maximum of, let's take Mayflies, we know that really well. Site 1 was 1, 2 was 6, site 3 was 2, site 4 was 5, site 5 was 16. They added that up, that's 30. So they had 30 total individual nymphs, Mayfly nymphs, for the pond study that year. So you have all those totals here. That's our big N. That's our richness of the sample. How many different species we have, this richness, the sample, we have good sample size because it adds up, it's over 100. That's key. If it's not over 100, it doesn't work. So we have 149 when we add that up. We have to multiply it times itself, minus 1 to get rid of any outliers. Just to round it off, we get this big old bad number here. And then you did it by individuals. So, and then you added it up and divided. The bigger this number is, the more diverse it is. So in 2007, when it was 19, or in 2013, when it was 12, those are big diversity years. So now we want to find out how diverse ours is. And so we're going to practice this math today. You're going to learn how to do this math well enough that when I give you the next test, it'll be on there as a multiple choice question to figure out. You will be able to do it. And yes, you can use your computer, your laptop, your calculator. Hello! I'm not going to call you Sarah. I'm going to call you Sam, too. So there. Take that. Okay, so we're going to try this out. Yes?
Were we supposed to just find the total of everything, or each?
Yeah, you're supposed to do this. You're supposed to take each of these. And
Yeah, I got that part. And
Yeah.
Then I divided the.
Yeah, so this purple, the big N is here.
Yeah.
It's over that, right?
Is that all we're supposed to do for last night?
Yeah. All you're supposed to do is just to try it. Because I don't want to have to teach the whole math here. I wanted you to struggle over in your own time. And you did it. So now let's apply it. Now applying is where we really deepen the learning. So let's deepen it. So first thing we have to do in order to find out our diversity index for this year from eBlock site is we got to make sure all our data is up. Where do we keep all that?
In the master spreadsheet.
In the master spreadsheet. Let's go to it. Everybody get in there. Let's take a look. We want to make sure it's good. So you're the, whatever site you have, you're the master commander. This is A block. So you're not writing in anything other block. So take a look at A block. I'm just going to use Site 4 is open, so we'll just use Site 4 as an example. Site 4 is already done. Site 4, you did a good job. Look, you've already done your max observations. You did not add up aquatic worms, you just took the maximum number, 4. Good job. Does that make sense? Yes.
This is just, for our blog post, are we writing it with our partners and then both posting it separately?
You're posted separately because your final part, the conclusion, has to be all your individual narrative.
But are we writing the rest of it too? Yeah.
Rest of it together, but
So we
you
only
post the whole thing on your own blogs. If you do only partials, you're only going to get partial credit.
Wait, that's for the final?
Yes.
But do
Yeah, wait, keep going.
we have a blog due tomorrow, like another one? Do we only have one?
We have a rough draft. You can just show me what you're working on. What you've worked on. Part of it would be this. What have you written? You've already written some of the general purpose because it was that initial blog post. Already got you moving on that.
I remember.
See how crafty I am? Yes.
So, wait, I lost my
Wait, so we can do the same, like me and DJ can do the same thing, just different conclusions? Or we get
Yes.
everything else the exact same?
Because you should have the exact same stuff, right?
Yeah.
You should double check each other's
Or
work.
we
You
should
should,
like, right, we can
But
just do it.
you didn't post it.
okay, wait. Silence. What was your question, Liz? You actually you can have the exact same words. I don't care.
Okay, 'cause that's what
It could be exactly the same. You can divide it up like Lucy. You could say, I'm gonna be, with my team, I'm in charge of methods, and I'll do analysis of biotics. You do this, you do that, you get the map, blah, blah, blah. Divide up tasks, okay? But make sure your language is good, proofread each other's, but the conclusion has to be all Lucy. It has to be all individual. If I see anything that's exactly word the same, I'm gonna come down like the house. Yeah,
For like pictures and stuff?
just cite it.
That can be the same, like,
Yeah, just cite it, right?
so it can look the exact same, except
Absolutely.
for.
See how easy this is now? Yeah, this is a lot easier than you think, because it's 10 years of data, you guys. You're going to be looking at a lot of data, so I don't want to give you a lot of work writing. I want you to work thinking. Okay, so ladies and gentlemen, let's come back here for a second to me. Look to me. I want you to focus on the biotic data today, getting it perfectly tight and getting the math perfectly right. Okay, so you can walk out and have that as part of your evidence. Because bad writing for this is when you say something with no evidence. No evidence, it ain't science. It's your opinion. I don't want your opinion. I want a science document. So let's do the math today. So each side, make sure your math, your observations are right, and then I'm going to guide you through this math activity.
Wait, so tonight's homework is just.
Start on a rough draft, right?
But no, isn't there more? Just some kind of video that you post.
Oh yeah, we're doing, oh yeah, that's right. Can I talk about the homework when we get to it?
Yeah.
Let's do this biotic stuff first. Let's not worry about homework yet. Let's worry about now. So look at your site, make sure everything is represented well, because we want to move to the next thing. So site 3, site 2, site 1, you need to put your data in and move over your max observed. Say site 5, the same thing. You need to move all that data over. You need to get that going. I'm going to give you 5 minutes to get that finished, because this is what you should have done already.
What is the max observation?
What?
Max observation.
So here's an example. Site 4, aquatic worm. They have 3 here, 4 here, and 4 here. The maximum they saw at one time is 4. It's not the addition, it's not the sum. It's just the max they observed. So for example, right here, midge larva, same thing. They didn't see anything else here, it's 12, so 12 becomes their maximum. Okay?
What's the average for the abiotics?
What's the average rate? Don't worry about abiotics today. Let's focus only on biotics. Because I want to get you to the point so we can do this math, this diversity thing, and get it right. Okay? Abiotics we're going to focus on tomorrow.
Okay.
Okay? Does that help? Okay, great. You have 4 more minutes to get your data in and make sure it's correct. Work as a team.
Okay. Remember that, right? Yeah. Oh, we're okay. Work this week is such
Wait,
We didn't do any. Oh, yeah, we did.
No, we didn't.
Okay. Yeah, because we only found 3.
Wait, why is it Mayfly?
Was it Mayfly?
Oh, wait, it is.
Thanks, good. Just to make sure our data is right. Good
Wait, we
work.
found
I bet
6
the
pictures.
Wait, I the pictures. I think I put the quotes on there.
The last day?
No, we shared it with third.
Oh, it didn't.
No, second.
Oh, wait, sorry. Actually, we did.
We could do,
5, I thought we were going to.
Well, we're waiting, I'll tell you what we're gonna do. So here's our focus. You guys already done this today. Focus on
Wait, what is this thing?
understand the answers to these questions. Because if you can answer 3, 4, 5, and 6, those are really key for your final conclusion. So we need data, diversity for the
yeah.
So that was 6, right? So 6 there. And then our last reading. So like, I need like corrected it. Graded. And then what was day 3 then? Really taking a photo of what we thought.
Yeah.
Yeah.
We found like 4 mayflies.
Yeah, you just need to I'm going to show you how to do it. With the
Or 5. We found 5.
For example, 2018.
On the 3rd day?
Yeah.
Split up.
Those are some red things, right?
Yeah, by like 2
Yeah, I got 3.
Whatever answer we get to B is be big. I'm going to take you through the steps. It'll make a lot more sense. Yes, sir.
4, actually 4.
And we really
And you don't do totals. It's just the maximum. So raise that. You're spending 7. The maximum you saw that's. We're going to add up. So like then we go across, back swimmer, let's get 8, we're going to add up across. Just the maximum. Okay? So we have to wait till everybody has the data.
What's a water?
Let me know when your site is done with your data entry.
Or is this
Yours is done. Your site 5. Site 5 is complete.
What's a water?
Site 4 is complete. Site 1 is complete. We're waiting on site 2 and 3.
We're done. We're done.
Site 2 is done, site 3 is finishing, right, Augie?
Done.
You're done. Okay, so here's our next step. Thank you. So our next step is we're gonna get onto the sheet of paper that's green. Just gonna grab Sam's. Okay, take a look at me. We're gonna, in previous classes, I had us do a lot of data crunching to make sure we get the math right, make sure last year's is correct. I'm gonna skip that step. We're gonna go to the very last page to 2018 to the A block class. Okay, we have a list of organisms here. Okay, and so what I'm going to do is, with your help, I'm going to go through and we're going to write down all of these organisms that are there. I'm going to show you how we're going to write it in. Oh, that's not. So I'm going to go to that page right here on screen using my iPad. And so you guys are going to help me. We're going to make a master list together. Okay, you're going to help each other. So-
Could you zoom in just a tiny bit?
Zoom in.
Yeah, it's better.
Is it better?
Yeah, it's better.
Fantastic. So first off, elderfly larvae. Do we have any?
No.
No. So I'm going to do that. I'm going to cross it out
Why don't we have any?
because we haven't found this species in a long time. Mayfly. So if we find mayfly, what I want somebody to do is to look at all the maximum numbers, only the maximum number column, and add them all up. That is for your total scene for the study. So you add up all the maximum observed mayflies for each site. How many is that? 11.
Wait, we have two. Mayfly.
Mayfly nymphs.
So wait,
that was,
17.
oh, I did the wrong one, sorry.
Okay, that's okay. This is why we're doing this as a team. Because math errors happen.
So that's 20.
You're adding up all.
All the
Wait,
maximum.
Mayfly nymphs?
We're
Sam says 21. Double check. Everybody has to do this.
Oh.
Math works better when there's a lot of people checking.
22.
I'm hearing 22.
15.
22.
Yeah, I got 22.
22.
Oh, I was just doing for just.
Yes. Wait.
Oh, no,
No,
and then I thought we were all gonna do
Yeah,
Just
I think
doing
it's
the
the
maximum number found for each site. So site 1 has,
One.
site 2 has,
7.
site 3 has,
10.
this 18, site 4 has,
12.
3.
No, 3.
so that's 22, site 5 has,
2.
so wait, so how does that add up? How does that add up? That's not 22.
Yes, it's 5, 15,
22.
16, 17, 18, 23.
It's 23.
Yeah.
Okay, good. See, that's why we gotta look at it. So that's what we need to do.
23.
So why don't you do this in your teams? Find out an animal.
Why'd you pick 2?
Oh shoot. What?
It's gonna be a 23.
I'm erasing. So this is how we do it. So we're putting the number in.
Wait, isn't it
It's
22
22.
times?
Sorry. You're right. My bad.
All good.
That's why we work as a team. Getting rid of errors.
Why is it 22?
Because n minus 1, we're doing the formula. I'm doing 2 formulas at once. Okay, dragonfly nymphs. What do we have here? How many? Work together. Have one team working on this one, another team can work on scuds, another on stoneflies. I don't think we have.
We have 1. Yes, there's only 1.
One dragonfly?
Yeah.
Total?
Yeah.
Is that true? Everybody agrees?
Yeah.
True.
Okay, so that, okay, good. Okay, scuds. Maximum numbers added together.
It looks like Dragonfly has 2.
You're looking at the maximum sites
6
for each site? Lucy? Look at it again. Find a discrepancy, I'm saying.
Wait, 6.
Why is this?
It's 2, right? Because
Ow.
it says max observed and then.
No, it's only, you're only counting the.
Why does this one say there was 4 one day, 8 the next
Okay,
day,
let-
5 the next day, then it said there was 8 total?
That's what you're supposed to do.
Because 8 is the
Because
highest.
8 is the highest one.
Okay, so the maximum observed is how,
So
the
we-
maximum of that species observed that day at that site. Or during the study at that site. And so we're adding the maximum observed at every site to get our total. So dragonfly's total should be what? 2?
No, it's 1. It's 1.
It is.
Um,
Because there's only
6 weeks.
As actually one.
And there's no other site that has it.
Just telling it.
Hey,
So Scuds, yes.
The Mayfly is wrong because, our group back for total, we we added them together instead of putting them higher. So we
Okay,
only have
so-
5.
All right, so correct that, then tell me what it was.
So 23 minus 6.
-5. Oh, -7.
11. So, and
It's
now.
good, we're working out the
so
details, it's the
Wait,
messy part.
6
11
tadpole.
minus 10.
You had 6 tadpoles?
Like for the max, for everyone's max.
Okay,
Okay, so.
all together,
All together.
6 every site?
No, like that's a
Wait, what
total.
was the biggest number? 5?
Well, for our
Thank
group,
you.
it was 5, but we put 7 because you found 2 and 5, so.
Somebody wanna do crayfish?
Go to 21.
No, you
Yeah.
subtract.
You say 2.
Why?
We don't have any
Wait,
stuff.
then why would you subtract 6 though?
Because
I think
you
I
subtract
subtract
2
two.
7.
Oh,
No, the highest.
If you have an error, make the correction in the data, so everybody can see how it adds up.
So you just subtract 2.
Yeah.
Oh, so just 21.
No. No. Wait, no.
Do we have any clams?
Because we put.
No.
Lulu, we did this
You
wrong.
guys put 7 in, right?
Or did we
Mosquito
put-
larvae, where are we at?
Oh, we're
We
doing
put 7.
For mayfly? Oh, yeah.
So it's 21.
So it's 21.
And then
And then
it's
20.
Yeah.
Okay.
So mayfly's
What did we
21,
do?
Oh, you only
11
put the
for
maximum?
Yeah, you don't add them. I think that's 7. And it's just fine.
crayfish, I need a number for crayfish, somebody, anybody?
Crayfish.
Double check their work,
I got you.
None.
0.
Yeah.
0?
None.
Alan,
Not even a site 1, nobody saw crayfish?
is there another packet?
No.
I could do mosquito.
I thought we had a stem for it.
Mosquito larva,
On mine.
1, 2, 3.
3, those were the maximums for all the sites, added together, 3.
Alan 22 for Copepod.
Ah!
Yeah.
Go back. Do we have any stoneflies? I'm assuming we didn't.
We have 1.
You had 1 stonefly?
Yeah.
So the total, is that what the data says on that sheet? Remember, you gotta not get, it's gotta be on the sheet.
I'll triple check.
Please. Let's move on. While they're doing that, do we have any caddisflies?
It's just, we had 1 stonefly.
Okay, 1 total stonefly. Do we have any frogs, adult frogs? Well, they're working for that, water boatman and back swimmer, any of those numbers.
Okay.
Double checking's always good. Let's keep, we gotta keep it real.
So there weren't any guys. 8 for back.
8,
8 total.
Yeah.
8. Okay. Water boatman,
0.
none. Aquatic worms,
4.
for every, is this the total number?
Only one group have them.
Only one group had, okay. Okay, spotted newts, we have any of those? It's like a salamander, anybody have a salamander?
No.
Minnows or a larger fish?
No.
Any snails?
No.
Not listed in
What's
there,
a
okay.
perch?
It's a type of fish. Midge larva, I know we had those guys.
Yeah.
Let's see what the total number is there, it should be pretty large.
35.
Somebody double check it. Crane fly larva, I don't think we had any of that. Didn't have any water pennies. Hugonites. Sobug, aquatic sobug, looks like a roly-poly that lives underwater. Anybody find one of those, like 5, maybe?
Wait, I got 38. No, I didn't buy it.
For midge larva?
Yeah, that's right. 12, 24, 30,
What's this?
35, 30.
Looks like a
Okay, yeah,
roly-poly that
it's
lives
fine.
underwater.
Yeah, it's 38 for midge larva.
38? Okay.
Yeah, 38.
Nice.
Great, see that, that's why we double check. There's no shame in errors as long as we fix them. Damselfly, nips.
There was 38 midge.
Yeah, midge larva has changed, everybody.
38.
It's changed it, yep. And we'll go over this again, make sure we have it nailed. Damselfly nymphs, what's our total there?
Damselfly?
Mm-hmm. Damselfly nymphs.
6. Yeah, 6.
Okay. 6. We didn't have leeches, we didn't have giant water bugs, we had copepods. DJ said it's 22. It'd be great to double check him. Beetle larvae we didn't really have. Culturefly larvae, no. So there's maybe some species that I don't have on this chart that I can write in. Are there?
I had springtails.
Springtails, good. Springtails are the same thing as snow fleas, just so you know
I had
that.
10 of them, but no one else picked any out.
So we have a total of 10.
What are they also called?
Snow fleas,
Snow fleas?
yeah, they're not wholly aquatic,
Are
but
they,
they're,
are they on this list?
No.
I just added them to it. You can add it to it, it's been on the other ones before. So you add it right in that slot, that empty slot.
Wait, do we have any sunflower?
There was one stonefly. It's right up here. Got them listed right there at the top of the screen right now. Peter?
No,
Okay. Is there any species on our list, on our studies that we found that we have not put up onto this this data sheet?
Can you scroll us the bottom?
I will. Yes.
Could you scooch over?
Am I in the way? Is that what you mean?
Yeah.
No, no problem.
I have one.
I'm gonna review the whole list in one second. What do you
I have
have?
a freshwater plankton.
Oh, that is the same thing as a copepod.
I did too, but I
So make sure that the plankton, we're gonna have that's all related to copepods. We're gonna put them in one group,
Okay.
because we can't discern. So does that change your number any?
yes, I would make it 23.
Yeah, it's okay, so we're changing this number. So now copepods are 23, okay? So I'm gonna review the numbers now. This is where we need to be critical, make sure we get the right stuff. We'll go to the top of the list, all right? Are we ready? Here we go. So, in review, mayfly, 21. Dragonfly, 1. Scud, 21. Stonefly, 1. Crayfish, 0. Clam, 0. Mosquito larva, 3. Tadpole, 6. Caddisfly, 0. Caddisfly, 0. Bullfrog, 0. Water boatman, 0. Back swimmer, 8. Water strider, 0. Aquatic worm, 4.
Wait, I think I got 4 for that.
4 water striders?
There's 4 aquatic worms.
Yeah.
Oh,
There, sorry.
No, that's good. No, that's good. That just saved you an error. That's awesome. So aquatic worm, 4. Newt, 0. Minnow, 0. Perch, 0. Snail, 0, 0. Now we're midge larva, 38. Cranefly larva, water penny, hogamite, sobug, 0s. Damselfly is a, yeah. Leech is a
0.
giant water bug,
0.
copepod,
3.
beetle larva,
0.
soldier fly, 0, 0.
10.
Okay? So now we are going to find our total, which is N. You can see that down here below in blue.
Wait, Copefly is 23.
Yeah, we just added to it. Yep. That's why we went over. Good. So we have N. So let's add that up. What do we get for N?
Oh, like all of them?
Yeah, so N is adding up that column. That whole column, that total. Everybody should do it that way to make sure we get the math right.
For the number of individuals?
But this column going straight down to number N, total number of individuals, our richness,
143, that's what I got.
143.
I got 142.
142. Keep going, everybody try it, we'll be able to suss out the error. If whoever it is.
142.
42, 142,
I got 142.
142 going once, 142 going twice. We got 142. So 142 times 141 is what? What do we have for n? Our number, oh.
The big number. Wait,
Yep, what's our big number?
1,200. Oh no, 1,700. Wait, no.
Hello.
Wait, 20,022.
20,022.
Yeah.
20,022.
222.
Nope, it's
20,000.
20,022.
Yeah. 222. Yeah.
2,222.
No.
Sorry. 20022. Sorry.
20,000.
Yeah,
Two.
22. Okay, there we go. Good. Now we have to do this next column.
22. Yeah.
Our species evenness column. So we're multiplying these numbers, you can put it here, and then we add all of them up.
Oh, wait, what?
Okay? Oh yeah, that's right. So we multiply this, put the answer there, repeat, then we add up that whole column.
I got.
Okay, give it a shot. It's important to know how to do this because I'm going to test you on it. So you might as well practice it. This is also a way we can eliminate the error of the math, right? You can do it.
I did too.
Doing great work. This is how math should be done. In big team setting, supportive, friendly. Not in a time situation, no talking. So I'm going to put the answer in green up here on this screen.
I got 2,976.
I got 2,920.
2,100. I'll wait till
Wait, yeah.
I got
Okay.
that too.
You got
And then I-
2,976.
Wait, what'd you go for 38 cents or something?
416.
2,976.
That's what I got, yeah.
That?
I got 146.
No, just 2,000,
40.
not 20.
Wait,
Oh,
I
I
probably,
That.
I probably, I probably.
37. Oh, yeah,
Anybody else?
146.
That's what I heard. It's like-
Okay.
I got 3,006.
You got 3,006?
Where the hell?
I got 2,990.
That's not. That's not right.
So remember the math, you're going to have two of these individuals that 1 times 0 is going to be 0, right?
I got 2,920. I got 2,976.
That's what I got.
I'm hearing a lot
I
of
got
folks. go to this one.
2,976.
Okay, so if we assume that's right, we put in our equation, we put this number
Number 10.
over our evenness.
It's hard.
Yeah, these complicated math stuff, there's a lot of room for error. So now we're going to divide our total pot, our richness by our evenness to get our diversity. What number do we get?
Let's find out.
See if it's close to the other blocks. We sample the same area at different times.
6.72.
6.72 is our first answer. We only do 2 Stinky.
Yeah, I got 6.727822258.
Okay, we could round it up into what I'm hearing. Interesting. Anybody get anything different? We all know how to do this, right?
Yeah.
Good. We could be, so, all right, good. We did it. We just did complicated math together.
Wait, why'd you have to 3?
Just cause.
But
Because
there's
it's
a
727.
Yeah, that's what I got.
No, I got
There's a
I
7.
got
7.
6.7211. I got it.
Oh, it's.
Yeah, it doesn't run.
All right.
So
Okay, wait a minute.
672.
Did anybody else get different?
No, I got a 7 after the 2.
I got
Yeah.
6.7. How am I screwing up a calculator?
Why is it?
I got 6.72.
Oh,
All right,
well,
so do that.
Wait,
yeah, 6.7.
Yeah.
Because on the one that you wrote under there, you put a 0, it goes 0,
I'm
2, and
so
then the one above
disappointed
it says
with
2,
my
2.
math.
Oh, snap.
Things like these.
Thank you, DJ. Snagging the error. Hey, guys, gals. DJ knows the error. I had a 0 here. So that's the actual number. Is it still the same?
then I think
Yeah.
it rounds
It's
up.
7.
Yeah, it is.
So it rounds up now.
Yeah.
7:30, okay. All right, so here's the next thing that's important now. This is really good for you thinking about how to write up the results. You're getting 6.7. I know. I'm going to tell you what, but this is important for you to follow. These questions here, you need to answer because it'll help you with writing the report. You also need to write in the other data points. You know, right here we have 6.73. The other class had 7.2 because they had different times of sampling, right? Different luck. But yours is what you're working with, okay?
Oh.
So you need to have the rest of the trend lines in there and answer these questions. You answer these questions that are on the sheet, you should put those in your blog. Because questions like, what's the overall trend, what factors are influencing the trend, are important parts of science thinking. You good? Before you go, slides here. The assignment tonight is calculating some abiotic stuff. It's about the importance of dissolved oxygen, which we don't have that data, but we have it from previous years, and I need you to know how to calculate that. It's math. It's a 20-minute explain everything video on how to do the math. Print up your worksheet in advance and work along with the video. It should take you probably 30 minutes if you work along, okay?
Okay.
Best of luck. You're awesome.
Where's the worksheet?
It is going to be attached to the assignment.
So Alex, it's should we work on a blog?
Yeah, you should be working on the blog with it. It is. The homework answer is penalty. Or more. You get close. Keep at it. You
I don't like it, Alan.
can do it, DJ. All right, recording's over. Good job, you guys. Good question.